Hi everyone. In this video, we are going to start dynamic programming with an array. So I took one problem from a LeetCode website. The problem name is min cost climbing stair. The question number is 746. So let's quickly see what does this problem say. You are given an integer array cost where cost of I is the cost of ith step on a staircase. That means we are given with an array and inside of that array we have some value that is nothing but a cost. Once you pay the cost, you can either climb one or two steps. Now it says that once we pay that particular cost, means once we are at any particular index, we can move to one more index or two more index. Fine. Means we have a choice that says that either you can go one step ahead or two step ahead. You can either start from the step with index 0 or step with index 1. That means inside of an array, let's say we have some value, random value 1, 2, 3, 4. So we have a choice either we can start from this particular index, 0 index or this index. Alright, now we have to return the minimum cost to reach the top of floor. Now guys, it says that you have to reach at the top of the floor. Also guys, let's see the constraint. Here the cost dot length means the length of our array will be less than or equal to 1000 and greater than equal to 2. And the value inside of array means cost is going to be less than equal to 999 and greater than equal to 0. I know guys, many of you didn't understand this problem. So let's quickly see this problem with this example which is provided on the LeetCode website as well. Now guys, we have an array here. Let me write this problem here as well, 10, 15 and 20. So we have this array means this cost. Now guys, we have to reach top of the floor. That is going to be somewhere here, means after of this array. So we are at 0 index or 1 index. We can choose any of the values. Let's say guys, I start climbing from 0 index. So I am at 0 index, fine. Now I want to move one step ahead or two step ahead. It's up to me. So let's say I want to move two step ahead. But for moving two step ahead, what I have to do, I have to pay this particular cost. So I have to say now my cost is 10 total cost, and now I can move from 0 to let me write a 0 1 2. So I can move 0 to 2. So I directly move 0 to 2 because I can take one or two step, right? So I move to 2 second index. Now still I am at second index, means I haven't completed this array. That means I didn't reach the top. So how I can reach the top? Once I completed this array, so I can take one step or two step here. Both step will make me outside of this array and I can reach the top floor. So let's say I take one step here. But for reaching a one step, what I can to do? I have to pay this much cost. So I say now my cost total cost is 10 plus 20, that is going to equal to 30. Now I reach at third index, which is not inside of our array. That means we can say that we have reached at the floor. Now I hope you understood this. What is this problem and how we can solve this? Let's see this now. So guys, first of all, we are going to discuss about top-down approach. I hope you have seen my first video. What is top-down approach? I have clearly mentioned there. Now guys, in top-down approach, we use recursion as I have already told you, and I'm going to consider the same array 10, 15 and 20. Okay. So I'm going to start from a 0 index or I can start from 1 index. That mentioned in the question, that right? It's up to us. So let's say I'm going to start from 0 index. Here inside of this case, I'm going to start from 0 index. Here I'm going to start with 1 index. Here I'm going to start my function with the 0 index value. Here I'm going to start with my function with the 1 index value. Fine. So now let's quickly move to this 0 index first. So in 0 index, either I can go to 1, I can go to 2. Fine. So I can go to 1, I can go to second, because it is up to us. I can take one step or two step. But once I reach 1, I have to pay this much amount, because moving from 0 to 1, I have to pay the cost of 0. So cost of 0 is nothing but 10. Alright. But let's see first of all that how this tree gonna work. So we are going to construct a tree now. So we are going to say 1, 2, we can reach 2, we can reach 3. Fine. And 2, 2, we can reach 3 and 4. From 2 also we can reach 3 and 4. But from 3 we can't reach anywhere because 3 is out of bound. We have 0. Here you can see that we have 0, 1, 2. Only 0, 1, 2 indexes. So we don't have index 3. So it can't move anywhere. We can't expand it. So we can say here we are going to return some value. And 3 also can't explore. This 4 also can't expand. And this 3 and 4 as well. So we have reached all the leaf nodes. Now guys, let's start backtracking. So here 3, let me change the color first. So I'm going to take this green color. Let's take it. So guys, what does this 3 represent? This 3 represent the index, and that index doesn't exist in our array. So we can say if it does not exist, then return 0. So it will gonna return 0. And this 4 also does not exist, it will also gonna return 0. Now guys, this 2 will, what it will do? This 2 will take the minimum value from left node or right node. So we can see that it is a 0. It is a 0. The minimum value will again a 0. But focus here. We have to add the value of this. See guys, we have to add the value of second index, because we can't move this 3 or 4 until and unless we don't pay the amount which is exit in this particular index. So 0 plus what value exit at the second index? You can see guys, the value exit 20. So we can write 0 plus 20. Fine. So this total will have, let me remove all these things. So this total will have 20, right? And 3 is also again out of bound, doesn't exist in our array, so it's gonna return 0. Now this one will gonna take the minimum value 20 and 0, which have minimum 0. 0 plus what is the value existing at one index? The one index we have 15, right? So 0 plus 15 means total it's gonna be 15. So at one index we have a 15 value. Fine. Now guys, now we have to expand this one. So let's see. So at second index, what we have? At second index, we have a 3 and 4. So we have to move again 3. 3 is going to return 0. 4 again going to return 0 because they are out of bound. Now 0 and 0, minimum value 0 plus second index value nothing but 20. Guys, did you notice we are expanding this again? Because these both are going to return same thing. So we, instead of expanding, we can use a memoization which will going to tell us that 2 already expanded. So just return 20. Fine. And 15 and 20, the smaller one is 15. So 15 plus the value at 0 index, that is 10. So minimum amount we can take 25 if we start from 0 index. Now guys, let's quickly see at 1 index. If we start from 1 index, then we can go to, let me take again this color. So we can go from 1 to 2 and 3, and 2 to we can go 3 to 4, and 3 to we can go 4. We can't go from 3 because 3 is out of bound. So we can say 3 is going to return 0. So let's make change again color. 3 is going to return 0, 4, 3 is again going to return 0, 4 is again going to return 0. So 0, 0, minimum value 0, and second index value we have what? 20. Now which one is smaller, 20 or 0? So we can say 0 is smaller, 0 plus 1 index value is 15, so total value is 15. So we are getting a value, minimum value 15, and if we start from first index, if we are getting a 25 if we start from 0 index. So which one is smaller, 15? So we are going to return 15. And also guys, in the example you can see the result as well. Let me show you. Here guys, you can see that we are getting nothing but value 15. So output is nothing but 15. Fine, I hope you understood it. So now guys, let's move to the code and see how we can write the code of top-down approach. So guys, here first of all what we are going to do, we are going to create a function. So we are going to say define the function name, let's say solve, and this function is going to take argument of index, right? Fine. And if index is going to equal to out of bound, so if index is greater than or equal to length of course, that means out of bound, then we can return 0. We have seen already it is a leaf node. All right. And if it is not the case, then we are calling two times. One time for one step ahead and second time two step ahead. So we are going to say return minimum of, let me call this function solve idx plus 1. That means index plus 1. So we are going to call first time for one step ahead, and second time we are going to call when we are taking two step ahead. So idx plus 2. I hope you understood this. Now guys, we are going to say something else. We are going to take the value of that particular node as well. So I have told you that whenever we are expanding it, we have to take that particular cost. So we are going to say cost of idx must be added while calling this function. So guys, that's all. Let's run this. This is a basic code of recursion. We haven't still memorized it. So we are going to first of all see whether it's working or not. So we are going to pass 0. First time we are going to pass 0. Second time we will pass from first index. Then we will take the minimum. So we can directly do this. We can say return minimum of solve 0 and solve 1. Now let's quickly run this code and see whether it's working fine or not. Still we haven't memorized it. Let me remind you. Here guys, you can see that both the test cases accepted. That means recursion code is working fine. Now we have to memorize it. We don't want to expand that particular node which have already been expanded. So what we can do, we can pass here dictionary. So by default, it's going to take an empty dictionary. Fine. Or we can give a name of DP as well. It's famous. Alright. Now guys, we are going to say every time we are calling it, we have to pass the TP as well. Fine. And here we are going to say one thing, that if that particular index in our DP, then we can say return that particular index, DP of IDX. We don't want to expand it again. If that particular index already in our DP means already been expanded, then don't expand again. So for that we have to store in our DP. So we are going to say every time. So I'm going to remove this return statement now. I'm going to say DP of IDX is going to be equal to this particular function. And then we can say return DP of IDX. Fine. Now guys, let's quickly run this code again. You can see that it's running fine. So let's try to submit this one. Here guys, you can see that it got accepted. That means it's working fine. We have done top down approach. Now it's time to do bottom up approach. Guys, let me write here bottom up approach. Bottom up approach. Again guys, if you haven't understood about this bottom up approach, you haven't know what is this, so you can watch my first video. The link will be in description as well. So what is this bottom up approach? We have already discussed. Now in this approach we use a tabulation method. We create a matrix, means an array, and we try to iterate over that particular matrix or array and try to find out the solution of sub problem. So here I'm going to take same example 10, 15 and 20. All right. And guys, we are going to create one more array which will be of same size. So here initially they will have a 0 value. Fine. Now guys, we know the first two value. We can either start from 0 or either start from 1. So we can say here the value first is going to be same and second also going to be same. These two will be default in every case. Here we have a length 3, but if the length will be 13 or let's say 1000, then again the first two value will remain same. We will start adding from second index. So we'll say 4 from second index to the length of cost. Okay, the logic is that guys, on every iteration what we can do, on every iteration we can say that on that particular array, let's say this is our nothing but an array. So array of I is going to be equal to minimum of, either you can take the last one index, so arr of I minus 1, or either you can take the last second index I minus 2. Whichever will be the minimum one, that will be taken. After that we have to add the current value, means current index value, that will be cost of I. So I hope now guys you understood this. Let's try run this code. So we have 10, 15 and 0 in our array. Fine. Now we are going to start from second index, so which is this. So we are going to take the minimum value, which is the minimum 10 and 50, that is 10. So what I'm going to do, I'm going to say 10 and plus cost of I, that is 20. So we can say 10 plus 20 is 30. So we can write here 30. And guys, you can see that now we are going to return what? 30 is not our right answer, but we have to return. We have to return the last two index value. We have to return minimum of last two index value, that is ARR of 2 and ARR of 1. So we have to return this last two index value minimum. Which one will be minimum? That will be returned. Minimum of ARR of 1, comma ARR of 2. So this is going to be returned. So here you can see that minimum is 15 or 30, 15. So 15 will be returned. So this is how this is going to work. And I know guys, it might be complex because tabulation method need a logic. So let's quickly move to the code and see how we can write this bottom up approach. So guys, I'm going to remove all this, or let me make it a comment. So here guys, what we are going to do, we are going to say, I'm going to create an array of same size. Initially all the value will be 0. So I'm going to say the length of cost. Alright. After that, first two value I told you that remains same. So ARR of 0 is going to be cost of 0 and ARR of 1 also going to be cost of 1. So I'm going to write in one line only. Okay. And here also. Fine. Now guys, what I told you, then we are going to start from second index. So I'm going to say 4 I in range, and here we are going to say from 2 to length of cost. Fine. And here we are going to say ARR of I is that particular index value is going to be, first of all we have to add that particular value. So cost of I plus minimum value, the last two minimum value, that is ARR of I minus 1. So let me write a minus and ARR of I minus 2. Alright. Now guys, what we can do, we can say that return the minimum value, return minimum of ARR of last one and last second, right? So in Python we can use a minus index. So minus 1 means last value and minus 2 means last second value. So we can return minus 1 or minus 2 minimum value. So let's quickly run this code and see whether it's working fine or not. You can see that both test cases are passed. Now let's try to submit this code. Here guys, you can see that it's successfully accepted. So we have seen bottom up approach, top down approach both. And I hope guys you understood the logic. If you didn't understood, you can write your doubt in the comment section. I'll definitely help you. So that's all in this video. If you like this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.